You know that moment? You're about to dive into your social feed. Your fingers fly across the keyboard. You type in the address, hit enter, and bam, you're there.
Mhm.
But have you ever actually stopped to think about what really happens in those, like, blink and you'll miss it seconds? We're going to pull back the curtain on that today.
Yeah, it's quite a hidden journey, isn't it? That single tap of the enter key kicks off so much. Especially, and this is what we're focusing on based on the materials you sent, when your browser is starting fresh. No memory of the site.
Absolutely. You've given us some really fascinating stuff to look at here. And our goal, our mission for this deep dive is to dissect that whole process, specifically that initial connection when the browser has a totally clean slate and empty cache. We want to walk you through all those steps to get you logged in and scrolling.
Okay, so let's start right at the beginning then. You open your browser, you type in, let's say, facebook.com was the very, very first thing.
Right. Well, the browser itself, Chrome, Safari, Firefox, whatever you use.
Yeah.
That's like your car for the internet. Yeah.
Yeah.
You've given it a destination name, facebook.com, but like a car, it needs an actual address, a specific location in the digital world.
And that's where the DNS, the domain name system, jumps in.
Yeah.
You can think of it as the internet's massive address book.
An address book.
Oh, yeah. We use names like facebook.com because they're easy for us humans to remember, but the internet, the actual network of computers, works with numbers. IP addresses.
Ah, right. Those strings of numbers you sometimes see.
Exactly. So that DNS lookup is crucial. It translates the name you type into the numerical IP address the computers need. Without it, well, you wouldn't get anywhere online. It's fundamental.
So typing facebook.com triggers this search, this lookup. The browser asks, hey, DNS servers, what number matches this name?
Uh-huh.
And it gets back something like, I don't know, 157.240.22.35 or whatever it is for Facebook.
Precisely. It's just like looking up a friend's phone number before you can actually call them. You need that specific number.
Got it. Now, for this deep dive, we're focusing on when the browser has no memory, right? This empty cache scenario. What exactly is the cache?
Good question. So the cache is basically your browser's short-term memory. It's a storage spot on your computer where it keeps bits and pieces of websites you visited before.
Bits and pieces. Like what?
Things like images, logos, style sheets, the CSS code, even chunks of JavaScript code, stuff that doesn't change very often.
Okay, and why does it do that?
Speed. The idea is next time you visit the same site, the browser can just grab those saved pieces from your computer instead of downloading them all over again from the website server. Makes things load much faster.
Ah, makes sense. So an empty cache means the browser has totally forgotten the site.
Completely. It's like visiting for the very first time every single time. It has no saved parts, no memory of previous visits.
It's like going into your favorite coffee shop and they have no idea who you are or what your usual order is. They have to start from scratch.
Exactly that analogy. So, okay, the browser has found the IP address via DNS. It has no cache memory. What's next to actually get that login page to show up?
Well, now the browser knows where to go. So it sends a request directly to that Facebook IP address, basically asking, hey, send me the stuff I need to build your login page.
Right. And the stuff it needs are primarily these core web files, HTML, CSS, and JavaScript.
Okay, let's break those down quickly. HTML, that's the structure.
The skeleton.
Yep, hypertext markup language. It defines the content and its basic structure like, here's a heading, here's a paragraph, here's an input box for the username, here's one for the password.
Okay. And CSS.
Cascading style sheets, that's the presentation layer. It tells the browser how everything should look. You know, the colors, the fonts, the layout, the spacing, basically the website's clothing and makeup.
Gotcha. Structure and looks. What about JavaScript? JavaScript adds the interactivity. It's the code that makes things happen when you click buttons, validates what you type into forms, updates parts of the page without a full reload. It's kind of like the muscles and nerves of the web page.
Muscles and nerves, I like that. So because our cache is empty in this scenario, the server has to send all of that, the HTML, all the CSS, all the JavaScript.
Every single bit needed for that initial page view. Nothing's stored locally yet, so it all has to come down the wire from Facebook servers.
It's like that coffee shop having to grind the beans, heat the milk, find the cup, everything just for your first order.
Precisely. So those files arrive at your browser, the browser reads them, and then finally it can render or draw the login form you see on the screen.
Okay, the form's there. Now you step in, you type your email or phone number and your password. These are your credentials, right? Your digital key.
Exactly. Your proof of identity. But sending that key, especially your password, across the internet, That needs to be secure.
Right, you don't want someone intercepting it. That's where HTTPS comes in, that little padlock icon you see.
Correct. HTTPS stands for Hypertext Transfer Protocol Secure. The S is the important part. It means the connection between your browser and the server is encrypted.
Encrypted, meaning scrambled. Like putting it into secret code.
That's a good way to put it. Encryption essentially scrambles your logging details using complex algorithms. So even if someone managed to eavesdrop on the connection, the data they'd see would just look like random gibberish. They wouldn't have the key to unscramble it.
Okay, like sending your key in a locked box that only the recipient knows how to open.
Perfect analogy. So your encrypted username and password safely arrive at Facebook servers. Now what?
Now, Facebook has to check if that key actually fits the lock, right? They need to verify it's really you.
Exactly. This is the authentication step. Facebook servers take the username you sent and look it up in their massive user database.
Okay, finds my account.
Right. Then it takes the password you sent. But critically, it doesn't compare it directly to a stored password. Instead, it uses a special process called hashing.
Hashing? What's that?
It's a one-way cryptographic function. It takes your password, runs it through an algorithm, and produces a unique fixed-length string of characters, the hash. It's designed so you can't easily reverse it to get the original password back.
Oh, interesting. So they store the hash of my password, not the password itself.
Yes, precisely. When you log in, they hash the password you just typed and compare that hash to the hash they have stored for your username, if the hash is matched.
Then they know I typed the correct password without ever needing to store or see my actual password.
Exactly. It's a fundamental security practice. So if authentication is successful, the hash is matched, they've verified it's you. They've checked your ID like a digital gatekeeper.
Okay, I'm authenticated. Am I in? Do I see my feed now?
Not quite yet. Authentication proves who you are. Now, the server needs a way to remember that you're logged in for the duration of your visit, so you don't have to enter your password on every single page.
Ah, okay.
So, upon successful authentication, the server creates what's called a session. Think of it as a temporary active login period.
Like getting a visitor badge after you show your ID.
Exactly like that. And to manage this session, the server sends a small piece of data back to your browser called a session cookie.
A cookie, I've heard of those.
Yep. In this case, the session cookie contains a unique random identifier for your specific session. Your browser stores this cookie.
So the cookie is like carrying that visitor badge around.
Precisely. Now, whenever your browser makes subsequent requests to Facebook, like clicking on your profile or trying to view your feed, it sends that session cookie back along with the request.
And Facebook servers see the cookie, recognize the session ID.
And say, okay, this user is already authenticated. Session ID 123XYZ is valid. Let them proceed. It avoids asking for your password repeatedly.
Clever. Okay, so I'm authenticated. I have my session cookie. Now do I get my personalized stuff?
Now the real personalization begins. The server knows who you are and that you're allowed in. The next big step is fetching all the data needed to build your specific homepage or newsfeed. This involves interacting with Facebook's vast databases.
Databases, right? These must be enormous, holding all the user info, posts, photos, friend lists, everything.
Absolutely enormous, and not just one database. They use many different specialized databases optimized for different kinds of data user profiles in one, friend connections in another, posts in yet another, maybe add data somewhere else. These are highly complex, often distributed systems spread across data centers globally.
Wow. So how does it find my stuff so fast among, well, billions of users? It can't possibly search through everything every time, can it?
No way. That would take forever. This is where database indexes are critical. Think of them like the index at the back of a huge textbook or tabs in a giant filing cabinet.
Okay, so they help find things quickly.
Exactly. Your unique user ID, for example, is likely indexed. So the system can very quickly pinpoint your main user record without scanning millions or billions of others.
So it finds my main record using my user ID. All right, what's a record exactly? And you mentioned tables.
Think of a table in a database, like a big spreadsheet designed to hold one type of information, say a user's table. Each row in that table is a record, representing one specific user, that's you. And each column in that row is a field, like name, email, user ID, date joined.
Got it. Table is the spreadsheet, record is my row, fields are the columns with my info.
You got it. So it finds your user record using the index. But that's just the start. Now it needs to gather all the related information for your feed.
Like posts from my friends, pictures they uploaded, maybe groups I'm in.
Precisely. This involves sending queries to the databases. A query is basically a structured question asked to the database, like get the 50 most recent posts from the friends of user ID 123XYZ, or find groups associated with this user ID.
And these queries might need to pull data from different tables or even different database servers.
Very likely, yes. Fetching your friends list might query one database. Fetching their recent posts might query another. Fetching suggested content based on algorithms looking at your past likes might involve yet another system. It's a coordinated dance across multiple systems.
And these algorithms deciding what to show me, that's happening here too.
Yes, the algorithms that curate your feed are running at this stage, deciding which posts, stories, ads, or suggestions are most relevant to you based on your profile, connections, and past behavior. They generate the specific list of content IDs to be fetched.
Wow. Finding my record, sending queries across potentially global databases, running algorithms, and this all happens in a second or two?
Often even less. It's an incredible feat of distributed computing and optimization. It really highlights the scale and sophistication of the infrastructure behind major social platforms.
Mind-boggling. Okay, so the server has gathered all this personalized data, my friends post relevant ads, my profile info. What's the final step to seeing it?
The server bundles up all this personalized data along with the necessary structural code like HTML snippets and sends it all back to your browser.
And my browser receives it.
And then performs the process called rendering. It takes all the code, the HTML structure, the CSS styling rules, the JavaScript for interactivity, and integrates your specific data into the right places. It essentially builds the visual web page you see on your screen from all those components.
So rendering is like the final assembly. Taking the blueprint, the paint, the furniture, my data, and putting it all together so I can see the finished room.
That's a great way to think about it. It's the browser painting the picture based on all the instructions and data it received. And that's when your personalized newsfeed finally appears.
Phew, what a journey. And then as I start clicking around, scrolling, liking things, the browser starts rebuilding its cache, right?
Exactly. As you navigate, it starts saving those static elements again, logos, common icons, maybe CSS files into its cache.
So it's like making copies of the stuff it expects to need again soon to speed things up next time.
Precisely. It's building that memory back up, preparing for your next visit or page load, aiming for that faster experience you usually get.
Okay, understanding all that.
Yeah.
Why is this important for us, the users, to know? Apart from just being, fascinating.
Well, for starters, it explains why sometimes after you clear your cache, maybe for troubleshooting, that very first load of a site feels a bit sluggish.
Because it has to download everything fresh.
Right. Nothing's pre-saved. It also helps understand why clearing the cache can sometimes fix website problems. If a cached file was corrupted or outdated, clearing it forces the browser to get a fresh, correct copy.
That makes sense. Does it relate to privacy at all?
It does in a couple of ways. Understanding the cache helps you know what kind of site data is being stored locally on your device versus what's always kept on the company's servers. And more importantly, understanding those session cookies really highlights security. That cookie is your active login token.
So if I use a shared computer, like at a library,
and you just close the browser tab without explicitly logging out of Facebook, that session cookie might still be valid for a while. The next person using that browser could potentially reopen Facebook and still be logged in as you.
Yikes. Okay, so always log out on shared devices. That's a key takeaway.
Definitely. It terminates the session and invalidates the cookie related to your login.
So it really is quite something. That simple act type, enter, wait a second, kicks off this incredibly complex, super fast ballet between your browser, DNS servers, web servers, multiple databases, encryption, authentication, all just to show you your feed.
It is. It's a hidden symphony of technology that happens billions of times a day. Mostly invisible, but absolutely essential to how we experience the web.
It really makes you appreciate the engineering involved. So maybe a final thought for everyone listening, now that you know a bit more about the intricate steps behind just logging in, what does that tell you about the constant conversation happening between your device and the vast internet infrastructure every time you connect? And maybe, what other everyday online things that seem totally simple on the surface, might have similar hidden depths and complexities going on underneath? Definitely something to think about.